In the next video, we'll discuss Graham's law of effusion. An unknown gas effuses at a rate that is 0.462 times that of nitrogen gas at the same temperature. Calculate the molar mass of the unknown gas in grams per mole. So we learned previously that effusion means if you have a gas in a chamber where we have a vacuum on one side and a gas on the other side, or a mixture of gases on the other side, and a small hole is opened between these two systems, then the rate at which the mixture of gases effuses is based, or moves from the gas side to the vacuum side, is represented by this equation. The rate of gas A to the rate of effusion of gas B is equal to the square root of the molar mass of gas B to the molar mass of gas A. In other words, the rate of effusion for each gas is inversely proportional to the square root of the molar mass. Okay? So, reading the problem again, an unknown gas effuses at a rate that is 0.462 times that of nitrogen gas. So what does that mean? It means that the rate of the unknown gas to the rate of nitrogen gas is 0.462. So the ratio of those two rates is 0.462. So 0.462 is equal to the square root of the molar mass of nitrogen to the molar mass of the unknown gas. Okay? And so the question asks us to determine the molar mass of the unknown gas in grams per mole. So we can solve the equation in this way. So 0.462 is equal to the square root of the molar mass of N2 divided by the molar mass of the unknown. So how do we get rid of the square root? Because we need to solve for the molar mass of the unknown. We need to get that on a side by itself. So in order to do that, we square both sides. Okay, and that gets rid of the square root on the right. So we have 0.462 squared, okay, is equal to the molar mass of N2 divided by the molar mass of the unknown. Okay, so now we can multiply both sides times the molar mass of the unknown. And that cancels out on the right. Okay, and then we'll divide both sides by 0.462 squared. Okay, so that gives us the molar mass of the unknown is equal to the molar mass of N2, which we can calculate from the periodic table. That's just 2 times 14, which is 28.02, divided by 0.462 squared. Okay, so that's going to be equal to 28.02 grams per mole divided by 0.462 squared. All right, so that is equal to 131 grams per mole. So if we go to the periodic table and we look at 131, our unknown gas is probably, let me move it over this way just a little bit. Well, molar mass is probably xenon. I can't get that on the screen, but the molar mass of xenon is 131. Okay, so now the next question says, find the ratio of effusion rates of hydrogen gas and krypton gas. So we're asked to find that ratio. So remember that the rate of gas A to the rate of effusion of gas B is equal to the square root of the molar mass of B to the molar mass of A. So we're asked to find this ratio. Find the ratio of effusion of hydrogen to krypton. So I'll just call the rate A to rate B the ratio. And so that's going to be equal to the square root of the molar mass. All right, let's go ahead and plug these guys in here. Instead of A and B, let's plug in what we have. So we're asked to find the ratio of H2 to krypton. So that means krypton goes here and H2 goes here. So that's 83.82 grams per mole to 2.016 grams per mole. So that's equal to 6.447. So that ratio is 6.447.